When I'm looking at a piece of technology, I like to ask myself a few basic questions. The first of which is, what can we use it for? So one thing we can use Ansible for is configuring servers or configuring hosts. So Ansible has a concept of a playbook, which is kind of equivalent to an operator's run sheet. Anything you can do by hand, by typing in commands onto a server, you can express as a playbook. And not only do you get a repeatable process, you can also apply that same configuration to multiple machines and then configure subtle differences between machines with group variables. So that's an example of what we can use Ansible for. We can also use it for ad hoc querying of servers to run commands basically as a distributed SSH runner. Same way as you'd maybe put SSH commands in a shell script. Now, a side effect of I guess, running Ansible to configure your servers is that you could also feed information from Ansible into your logging and metrics gathering system. So you can perhaps trigger alerts of failed Ansible tasks, or perhaps measure the performance of Ansible tasks. And we'll touch on that a little bit later on. So now that we've asked ourselves that question, the second question I like to ask when I'm looking at a piece of technology is, where did it come from? What was its origins? Where is it at right now in terms of popularity, development effort? There are certain things you can look for which can inform your expectations for the experience you're going to have with the piece of software. So for Ansible, the place to look is Ansible's GitHub project. Now the main repo is a repo called Ansible. There's also modules, extras, and modules core. Now the modules were recently split out from the core Ansible repo to ease maintenance. We're not going to look at them right now. We're just going to look at the main Ansible repo. And the things that we're going to look at are, commits. Alright, so this project has had 27,000 commits, which is a very busy project. That's a lot of commits. It also has 2,400 unique contributors, which, again, that's a lot of people contributing to this project. It has plenty of stars. Whether or not that's a useful metric, I'm not sure. The fact that there's over 1,000 issues which are open may be a little concerning, but it would depend on the nature of the issues. Not knowing these bits of information can help inform our decisions on how we use the software. So a little while ago I cloned this repo, and one thing I sort of like to do is, by looking at the UI, we've got this sort of snapshot on where the project is right now, but I'm also interested in where the project came from. So if we have a look at the very start of the history, say the first 40 lines of the history, we can sort of get a glimpse on what the original author was thinking when they started it. You can see the very first commit is by Michael DeHaan in 2012. We could check out that commit and just have a look at what's there. We have a README file and a lib directory. If we look inside lib, we can see like a lot of Python projects that started with a single Python module named after the project. If we have a look at the README, maybe that will give us some clues on the intentions of the project at its genesis, like the commit says. So Ansible is an extra simple Python API for doing remote things over SSH. That's nice and concise. Unlike some configuration management systems, Ansible is push-based, and it uses SSH to basically coordinate and manage the configuration. If we look at the principles, also some interesting stuff here, like dead simple setup. If you only need an SSH connection, you don't need an agent running on the remote machine, then that is that is simple, about as simple as you can get. I guess the other thing that that can tell us some useful things about a project is what the installation is like. So we'll use a couple of VMs that I've set up. I'll use a Linux and an OpenBSD rather. The Linux I'm using is just the latest Ubuntu LTS. We're going to SSH into that, and we'll SSH into our BSD VM as well. So while we're waiting for that, I can say that there's a couple of main ways to install Ansible. The first being installing from whatever operating system packages come with the operating system you're using. The advantage of that is if there are binary dependencies, compilation dependencies, then that will be taken care of by the package manager. Downside is it's often not the latest version of Ansible, but I think it's a place to start. So before we talk about the other ways of installing Ansible, let's just make a start on installing Ansible via the package manager. So we're going to do an apt-get update on Ubuntu, and on OpenBSD we need to specify a mirror to install our packages from. So we're going to export the environment variable package path, and in this case I'm going to use ftp.au openbsd.org pub openbsd 6.0 packages md64. As far as I know, there's no way to query the available, search for the available packages in OpenBSD, but we can just download the index.txt file from the package mirror and grep that. So that's what we'll do. And we'll go grep ansible index text. We can see there's a package called Ansible, and on the Ubuntu side we can do an apt-cache search Ansible, and similarly we have a package called Ansible. So let's go ahead and install Ansible on Ubuntu with apt-get install Ansible, and on OpenBSD we can do a package add Ansible. Oop. I need to hit yes for Ubuntu. Alright. Now I think the base box I'm using for OpenBSD already has Ansible installed, so we're not really seeing much there. There's a bit more action happening on the Ubuntu side because I'm pretty sure we didn't have Python installed when it started, so most of the dependencies are installing Python. So we'll wait for that to finish, and we'll just do an ansible -- version on each just to verify that it's available. And then we'll look at installing Ansible via pip, which is a common Python package manager. So on OpenBSD we'll do ansible -- version, and it is at version, should be 2.10. 2.10, good. And on Ubuntu it's almost installed. The package manager says that it's going to be 2.00, which is a little bit older. Ansible -- version 2.0.0. Good. So, we have Ansible installed, it's all ready to go, but let's go ahead and install it again using pip. And we'll also install it inside what's referred to as a Python virtual environment, which is simply just a directory which holds all your Python libraries. So rather than dumping them all in user local, we dump them into a directory, and that enables us to isolate our non-standard library Python modules on a per directory basis, which can be very useful if you want to test with different versions of Python packages. And it also saves you from cluttering up your system. So let's see, we need Python virtual environment. To install that, we could use easy install, but we may as well use pip. But to install pip, because it won't be installed by default, I don't think, On Ubuntu, we'll need to do an apt-get install python-pip, and on go yes. And on OpenBSD, we'll need to do a package add. Actually, I'm not sure, so let's grep for pip inside index text. There's a pypip, good. So we'll go package add pypip. That should be all we need to do. Now, if you look at the dependencies that are getting pulled in for Ubuntu, a telling one is GCC. So pip, some Python modules are written in C, so they require native compilation. This can make installation via pip more brittle because you don't necessarily always have the right development headers for the right pieces of software. So now that we have pip installed on almost both machines, we'll use pip to install the Python module virtualenv. This is probably also available via the operating system packages, but we'll use pip anyway, just not for any particular reason. So probably worth noting that virtualenv, well, the stripped down version of virtualenv comes bundled with Python 3, so it's not an extra step that you need to perform. But for now, Ansible is Python 2 only, so it's something that we need to install. Okay, so we have virtualenv, pip, Python, Ansible on the system. At this point, we don't need to do anything else as root, so I'll drop back to my Vagrant user. Where am I? Home Vagrant. I'll create a project, could be any directory at all, which we'll let virtualenv create that for us. So we'll go Python 2.7-m for module virtualenv, and we'll give it a directory called PEO, Peter Ericson's opinions. Okay, so actually we've just installed Python pip, but we haven't installed virtualenv yet. So let's go sudo pip install virtualenv, and then we'll repeat that previous command. Should be fairly quick. Good. Repeat that previous command. Alright, so now we have on each machine in our unprivileged user, we have a directory called PEO. But if we go PEO/bin/pip, now we can run our isolated pip version copy. And anything that pip installs will be within the PEO directory and not on the system. So if we go PEO bin pip install Ansible, that should give us the latest version of Ansible, which should be around 2.2. We'll do the very same thing on Ubuntu. And let's see if we run into any issues. We may, because even though Ansible is a Python project, it does have a lot of dependencies, and at least some of those dependencies require native compilation. So we'll see. So both Ubuntu and OpenBSD are downloading the tarball for Ansible 2.2.0. That's not the tricky part. The tricky part will be PyCrypto, I think, or OpenSSL. So I don't know. So what are we learning so far from this process? I guess we can say that in some ways Ansible is easy to install because it's just a Python dependency, and if you're familiar with Python especially, I mean you're used to to wearing the overhead of installing Python modules in a similar way that if you were used to Ruby, you'd be used to the overhead of installing Ruby modules via gem. I mean, it's clear that this is significantly more complex than just dumping a precompiled binary into your bin directory, but it is what it is. Certainly, installing whatever version of Ansible comes with your operating system via its packages is a lot easier. You might not always get the latest version of Ansible, but maybe it doesn't matter. If you get to, okay, so say your workstation, say that you don't want to match your workstation OS with whatever OS you're running on your servers. In that case, you probably want to use pip on your workstation so you can exactly match the version of Ansible that you'll be running on your servers. That would be a sensible thing to do. And if you use virtual env, then that's even better, because that would allow you to easily switch between Python versions on your workstation. If, say, there was a major new release of Ansible and you wanted to, just start developing with it to see if there's any sort of obvious breakage introduced from the new version. Alright, so we're seeing a problem with the pip install on Ubuntu. It looks like GCC has failed somewhere, which is likely to be some kind of missing headers, a missing development package, maybe missing static libs or headers. We'll wait for it to conk out and then we'll see what kind of information it gives us to debug with. Alright, so pip on Ubuntu is telling us that there's no such file as OpenSSL, OpenSSL-v.h. Now, if I had to guess, I would guess that we're missing some kind of package which has the name SSL, and it also includes dev. So let's do an apt cache search SSL and dev. See what we can find there. Alright. libssl-dev. I'm pretty confident that's the one. apt get install libssl-dev, and then we'll try again. Okay, so we have libssl-dev installed on Ubuntu, so let's retry our peo bin pip install Ansible. Hopefully we can get all the way to the end this time. Meanwhile, OpenBSD is still chewing away. It is running setup bdist wheel for cryptography. If it's bdist, that stands for binary distribution. So I'm thinking there's some compilation going on there. So I think all in all, it's probably going to take us about 20 times as long to install Ansible via pip than it is just to use the operating system packages. But like I said, I still think this gives us some insight into the complexity of the software. You certainly shouldn't be left with the opinion that Ansible is just a Python dependency, which you can just go pip install Ansible. Did I say dependency, a Python package? It's a little more complex than that, in part because it's depending on cryptography and PyCrypto, which I think both have some C dependencies, which you require full GCC toolchain to install. But all good. There's a difference between what kind of complexity you're willing to accept in your development environment versus what kind of complexity you're willing to accept on the servers that you're deploying to. It's just all part of it. So we will come back and verify that our pip install Ansible works, but for now we're going to go ahead and have a closer look at Ansible itself. Well, we're going to have a look at how you might use Ansible. Now we could do the same thing on either system. I'm going to use OpenBSD this time, but we'll see how we go. We might switch between the two. So the first thing that I want to cover, I was going to cover roles first, but I can't really demonstrate that until we have a little some other infrastructure in place. So let's just leave it as the basic building blocks of Ansible are playbooks, and playbooks can include roles, and a role is a way to encapsulate functionality for a certain thing in its own directory with its own set of default values, templates, files, and playbooks. We are logged in to our VM. We're not going to use the pip installed version of Ansible. We're just going to use what's on the system, which is version 2.10. We're going to create a directory for this. Let's just call it test, inside test. You know, it's an empty directory. Do we have git installed? No, we don't. Okay, let's not worry about that just yet, but we do need to start creating some files. Alright, so you've got your project directory, it's empty. First thing you need is a hosts file. So we talked about before how Ansible manages machines over SSH. Well, we need a way to tell Ansible which machines it's managing. Now there are defaults for where hosts would live on your system. I believe it's etc. Ansible, but when I'm using Ansible, I tend to like to have that hosts file, playbooks, roles, etc. all in the same Git repo, so it can be under version control, and I can manage the source for the Ansible infrastructure in that way. So let's create a hosts file. We're just going to call it hosts. Now, most of Ansible is configured using YAML files. Hosts is a little bit different. It is more like a sort of an INI style config file. By default, if you don't have a hosts file, Ansible will default to having a single host called localhost, which has its connection set to local instead of SSH. So even though we said that Ansible uses SSH to manage machines, it can also use a local connection to manage the local host of whatever machine Ansible itself is running on. So let's start with that. We'll define a host called localhost, but we're not going to override it and say this should be local. We want to SSH to localhost basically, and pretend. Well, I treat it in the same way as we'd treat a remote host. So it should be enough just to say the name of the host is localhost. In general, you have one host entry per line. Now, if I was to create a playbook, by convention, I would call it site.yml, and the default location, again, for this would be maybe etc. Ansible site, but like I said, what we're doing is we're sort of putting everything in the same location so we can keep the files under version control. So a slightly different pattern from, I guess, plonking the stuff down onto the host operating system to manage a host in that way. So we're going to keep this really simple. We're going to basically have a single play against all hosts, which will just be localhost, and we're going to specify some tasks. We're not going to specify roles, just tasks this time. We're going to give our task a name. Actually, we're not. We're just going to say it's a shell command, and the arguments for the shell command are just echo here. So if you're new to Ansible, then this might look a little bit strange. It's worth noting that this is in YAML format. We've got -- to start the YAML file. A single dash at the start of the line here means that we're starting a list. So this whole block here is item number 0 in a list, and that's our playbook. The list has 2 dictionary keys. One is called hosts, which is required at the play level, and here we specify what hosts this play should happen on, and we're saying all. Next key to this dictionary is tasks. We can either have tasks or roles, but because we're not using any roles yet, we're just going to have specify tasks. And again, it's a list of tasks. In our case, we're only specifying one list item. We're using the Ansible module shell, and we're giving it a freeform set of parameters, which is just the shell command we want to run. So if we leave that open, we'll just make sure we save it, and we'll go into the machine and run that playbook. And we'll just have a look at what output we get from Ansible when we run something. CD into our test directory. There's a hosts file, a site.yml playbook. Now we'll run ansible-playbook-i for inventory, specifying hosts, and then the name of the playbook, site.yml. This is going to attempt to SSH to localhost, which may or may not work. Okay, so in this case, we've never SSH to localhost before, so we're getting the standard fingerprint confirmation. We're going to go yes. Now we've failed to connect to localhost. That's okay. Probably what we need to do is check to see if there's an SSH key on this box. There's not, so let's create one, SSH key gen. The default is to go to home vagrant.ssh.idrsa. All good. You don't need a passphrase in this case. Now if we look again in home vagrant.ssh, we can see that we've got an ID RSA, which is our private key, and an ID RSA.pub, which is our public key. The private key is only readable by Vagrant. Public key is readable by anyone. That's all good. But we need to append our public key to our set of authorized keys. So we can do a cat.pub and append to home.ssh authorized keys. At this point, we should be able to do a SSH localhost. All good. So now, if we run Ansible playbook again, it should be fine. Okay, what's going on now? Python not found. Alright, so on OpenBSD, non-base software is installed into user local. Ansible by default will expect Python to be available as user bin Python. Let's see. This time. Setup was successful. Alright, so it's worked. You've now seen the most boring and simplistic Ansible run that you'll see. I'm just rerunning with -v for verbose because I want to verify that the shell task returned some information, including that standard out included the string here. And we can see in the output that indeed standard out consisted of here, because we've echoed here, standard error nothing, and we also have the variable standard out lines. Now that it's quite useful to have a look at this, because any of these keys we can use in conditional tasks. We can register the result of a task and inspect that result and decide what we're going to do depending on what it includes. But we don't really need to talk about that right now. Just before we move on, let's have a look and see if our pip install Ansibles have finished. They have. Looks like it's worked. Now if I go peo bin Ansible version in Ubuntu, we can see that we have a copy of the latest Ansible 2.2.0, very good. And if we do the same on OpenBSD, PEO bin Ansible version, then same thing. So virtual env is good because it enables us to install whatever version of Ansible we like without messing with the host system, and we also don't need root access to do so. But we're just going to continue using the OS package provided version of Ansible. Alright, good. So, you've seen the very, very basics of playbooks and inventory files. What we're going to cover next are roles. And, it may be a little bit early to look at roles, but I think it's a pretty fundamental aspect of Ansible, so I don't mind covering it early. So before we continue, my lack of syntax highlighting is it's bothering me a little bit, so let's go ahead and install a decent editor. I might just do a package add -i for interactive Emacs, and we'll see what our options are. I don't want to install a version of Emacs which has X Windows support, because that will bring in a whole bunch of packages that I don't need. So we'll look for a no X package. And what have we got? Emacs 24 no X. Good, that's what we want. So again, we've got a directory, we've got a hosts file, which is the inventory, we've got a site YAML, which is the playbook. Now we want to add some roles. Make directory roles, cd roles. Now the way I like to make roles, I find this very convenient, is to use a command called Ansible Galaxy, which comes with Ansible, and you can go Ansible Galaxy space init in the name of the role. So what do we want to install? That is a very good question. Possibly Emacs, right? Because we just installed it by hand. But no, we'll do something else. We'll say we want to... No, we will do Emacs. We'll say we want to create a role that configures Emacs for us. Because remember, we need to add support for YAML, because it doesn't come by default with Emacs, I think. But if it does, we can change direction. So the point is, I'm making a role called Emacs. Ansible Galaxy will completely flesh it out with all the directories we need and some that we won't need, but we'll talk about an easy way to clean that up in a little while. Let's check back. Emacs is still installing. We're going to install Git as well, because we'll use that to good effect. Alright, so we have a directory called Emacs. Let's cd into Emacs. Just as a reminder, we're in roles/Emacs right now. Okay. So what Ansible Galaxy gives us, it gives us a README file, which we can fill in, a default Travis YAML, which we'll ignore for now, a directory called defaults, which we can put our default variables in, a directory called files, which we can put any files that may need to be installed on the remote system, but don't need to be templated in any way. Handlers is a mechanism to trigger things to happen at the end of a play, for example, restarting of a daemon. Metadata is a way to specify information about your role if you're looking to share it on Ansible Galaxy. Tasks, set of playbooks, one or more. Templates, a place to put files which you might need to substitute variables into. Vars, similar to defaults but a higher precedence. And tests is a way to create tests for your roles, and we should probably have a little bit of a look at that as well. But we may not cover it this time. So we've got an Emacs role. What does it actually do? Well, we should probably add a task to actually add Emacs, and that would be a good place to start. So now we're on OpenBSD, so we don't have apt, we don't have yum, we do have package, but I'm not sure if that is the correct module to use on OpenBSD. So usually at this point what I'll do is I'll Google, let's see what we get. Oh yeah, okay, so the module is just called OpenBSD package. So what we find with Ansible is that most packages will have a variable called name. That's quite a common one. And a lot of them will have a variable called state as well. Sometimes the state is, there'll be a default state, which is what you want. Other times you need to make it explicit. Whenever you Google Ansible role name role and you find a page, then you can go through and it'll have a list of parameters with their defaults. So the one is commonly for all the package resources, you have the option to go state equals absent if you want to remove a package, latest if you want to handle upgrading a package, or just present if you just want it to be there. In this case, we just want Emacs to be present. Let me just remind myself what the package name is called. Very good. Good. State x11 state equals present. So fairly simple, and that should be enough to verify that that Emacs is present on this system. So let's actually run that and have a look at the output. We'll go back to site.yml. We don't need our echo here anymore. That's not very useful. We need to get rid of tasks, replace that with roles, because in this case we're applying a single role to our list of hosts, and the role's name is Emacs. Right now I want to be a little more specific, and I'm going to say I only want to apply this to the local host role. That would actually be the same as all, because our all group has only one host, but I'm going to do it anyway. Alright, so you can see our playbook, I should say, consists of a single play against the host localhost, applying the role Emacs. And when we run that with ansible-playbook-i hosts site.yml, we should see it tell us that we already have Emacs installed. But one thing that we haven't done is we haven't told our play to use sudo. So even though it's passed, I would say if it had tried to install, it probably would have failed, because it would be running as the Ubuntu user rather than as root. But all good. So far so good. Now let's go back to our detour. We installed Emacs. Good. It's installed. Another slight detour is I'm just going to install Git, but let's ignore that for now. Let's go back to our other window. Now let's load up Emacs, right? So Emacs dot. We've got our directory tree, all good. Let's load up site.yml. Okay, so it's not color, there's no syntax highlighting. So what that tells me from experience is we're missing the YAML mode, not included as in the default set of packages that Emacs comes with. There might be an operating system package for it, but we can also install it via malpa. Now, we need to add some information to our home directory .emacs so that we can run the malpa install to install YAML mode. So let's handle that as part of our Emacs role. So our role is going to get a bit better now. Not only will it install Emacs, it will also set some default configuration, which makes it more useful. Yeah, I mean that's good, right? So let's go into our role. We've got our Emacs role. One of these default directories that are included is templates. Now we want to create a .emacs template. So we can call it .emacs. A little bit unfriendly if you're just doing an ls without -a, but let's go with that. We'll call it .emacs. Now by convention, our templates have the extension J2. Don't have to, but the convention is to include that. And J2 is a Ginger 2 template language extension. Ginger 2 isn't specifically for Ansible, but it is a templating language that the Ansible project chose. And I quite like it. It works quite well. So far our emacs.emacs.j2 template is completely empty. We need to add something into this. Now, I haven't done this for a while. I probably could just look at another copy of .emacs that I have on a different system. the largest and most up-to-date repository of Emacs packages according to its blurb. And there should be some information in getting started. Let's have a look. Alright, so it's telling us what we need to do is add this Emacs Lisp code to our .emacs file. Certainly this is a tangent for a talk about Ansible. That's alright. So we're not actually in Lisp mode. Let's just change to Lisp mode and we'll get some nice indentation, color syntax highlighting. There's a block here that says when Emacs is less than 24. We don't need that. Let's get rid of it. So what we've got here is require package, add to list, package archives malpa, then the address of malpa, package initialize. Cool. That's all we need. Now, this could have actually been a file because we're not substituting any variables. But, you know, for demonstration purposes, why don't we do that? So what we could do, we could set a default list of package archives that we want our Emacs role to add. We'll add that into defaults main. And we will simply call it Emacs underscore package archives. We use Emacs underscore as a convention. It just makes it a little cleaner. So if we're overriding this in group vars, so if we're overriding this default variable on specific groups of hosts or specific hosts, it'll be obvious by its name that it's you know, doing something related to the Emacs role. Okay, so what do we want to do? There's a tuple. It's a list of tuples which have name of package and URL. I guess we could keep that convention. That's it's all right, but it might make a little more sense if we just go say a name equals malpa and I don't know URL equals the URL. Let's do that. I can't wait to get YAML mode installed so we have some syntax highlighting here. But I think you can see from this is, you know, we've added a variable to our role which is called Emacs package archives. It is a list with a single list item. The list item happens to be a dictionary with two keys, one being name, one being URL. Now somehow we need to substitute that into our .emacs Ginger template. Yeah, sure we can do this, not going to be a problem. First of all, let's just kind of give ourselves a bit of white space here to work with. We're going to need to do a Ginger for loop. Now, Ginger variable substitution happens in double curly braces, but if we're doing some kind of control flow, then it's curly brace %sign. I'm actually going to have to look up the syntax just because I always forget it. Alright, so here's an example where it's a for loop example. That looks pretty good to me. I'm just going to have to take it off screen, but I'll type in something similar. I'm going to say for item in Emacs package archives, and then I'll close off that, and then I'm also going to do end for down here, close that. Now item, the syntax is going to be item dot dictionary key, so item dot name for the first element of the two. Actually, it's not a tuple, is it? It's a pair. Never mind. And then the second one is item dot URL. Cool. Let's take away white space because we don't need that anymore. We'll have a look at the generated template afterwards. It's going to be, there's going to be some extra white space that we wouldn't usually have in there, but there's a trade-off between, you know, how the end result looks like and how readable the template is. So I'm prepared to make that template, that trade-off rather. All right, good. So now that we've created a template for .emacs.j2, we've given it relies on a variable which we've set a default for our role. What we need to do is modify our tasks for our Emacs role to actually do something with this template. So the syntax for that is template, and instead of using a simple string with equal signs to do key value pairs, what we're going to do is we're going to use a dictionary syntax instead. It's equivalent. It just depends on, I guess, how long you want your lines to be, how readable you want it to be. For a template, we're specifying a few extra keys, so I like to use the longer form a little bit. So source is simply .emacs.j2. Because we're doing this inside the context of a role, we don't have to specify template slash. We have to specify a destination, and in this case it's going to be in our user's home directory. Now, the user on this machine is Vagrant. Let's have a look. It is. Now, this is not cool, but what I'm going to do is just set the destination. I'm going to hard code home Vagrant. You're not going to want to do this, but I'm going to leave this in for demonstration purposes because we've already covered some advanced topics by doing a for loop in a template. So rather than trying to find a global Emacs configuration file, we're going to keep the trade-off that the destination for our template is a specific user's home directory. So destination is home vagrant.emacs. Now we could set owner and group. Let's do that. So owner vagrant, group vagrant, and we'll do it mode just for the heck of it. Doesn't really matter. Now, what's going to happen when we run this? Let's find out. So again, we'll go ansible-playbook hosts site.yml, and this time we should end up with a file .emacs created, variable substituted, and we'll be one step closer to having syntax highlighting for our YAML files. Right. Let's cat.emacs. All right, and as you can see, malpa and the URL for malpa has been substituted in, and that's all good. Now, I'm not going to add the installation of YAML mode to Emacs in this role right now. I'm going to do it from within Emacs, package refresh contents. It's the name of the function. See, it's connecting to malpa, and I'll do a package install YAML mode. Cool. All right, good. So now we are able to see some color in our YAML files. Very good. Now you'll note that I installed git just before. That's because I want to do a git init. And the reason I want to do a git init, git status, is because I want to remove the files in our role that we haven't touched yet. In roles, now we've modified defaults main.yaml, so we definitely want to keep that. And we modified tasks main.yaml, so we definitely want to keep that. Didn't actually do anything else, so maybe we'll try that again. Okay, this time. Our revised role doesn't have a readme, probably should, but we're not going to add it right now. Our role is simply two directories. The first directory is called defaults, and it has a main.yaml, which is specifying the default Emacs package archives variable, which we can override in other places. but it's always good to add a default to your role, a sensible default, so you don't get missing variable errors when you run your play. And the other thing that's in this role is a single playbook and tasks called main.yaml, and it installs or ensures that a package, an OpenBSD package called emacs nox11 is installed, and it also creates a .emacs file in a specific user's home directory. Like I said, this role is not particularly useful other than for demonstration purposes. Now, something else you might have noticed is the output just said OpenBSD package template. It's not actually telling you what's happening, so it's good practice to give a name key to all of your tasks and your plays if you have a recent version of Ansible, more than Ansible 2, and that way you've got better descriptions in your Ansible output, which is also nice if you're going to use your Ansible output as an input to your logging system. So it's up to you to find a convention that sort of works for your needs. I would just strive for consistency if you can. So here I'm just going to say this. I'm going to call this this task install Emacs, and I'm going to name this task create.emacs for vagrant user. So let's see what that looks like when we run Ansible. Alright, so we've got the name of the role, which is Emacs, and the description of that particular task, which is install Emacs. And then we've got create, the next task is role Emacs, and the name is create.emacs for vagrant user. Now that one's actually failed. Oh, you know what we've done? We've actually accidentally removed our template. That's a bit of a pain. Alright, we'll just have to re-add it again this time. Alright, so yellow means that it's changed, and I think what we'll find is if we cat.emacs, it might look a little bit different. Yeah, so the alignment is a little bit different. Now, if we were to run ansible-playbook again, what it should say is, it shouldn't say changed for .emacs, because unless there's something about the template which is non-deterministic, we should be writing out the same .emacs file every time. So I guess another thing that Ansible does, which a shell script's not going to give you out of the box, is it does have a concept of idempotency. I'm not sure if I'm pronouncing that correctly, which basically just means that it will only change things that need to change. So we're going to look at what a dynamic inventory is. We talked about inventories before, and we discussed that it is a INI style, one line per host entry, optional groups, which we haven't looked at. Actually, we want this to be a script that gets run every time and possibly looks up our inventory from, say, a cloud provider or something else. But we're not going to look at a cloud provider, we're just going to basically do the exact same thing. We're going to make this a script. Let's make it a Python script. Now, the syntax for dynamic inventory is basically just JSON. You have to return JSON on standard out. I can't remember it off the top of my head, so I'm going to look it up, but we'll figure this out the hard way. Okay, so this is our Python script, and we're going to have a data structure which we will return to standard out. JSON and sys. Localhost will need to be quoted. Okay, so what do we need to do? First of all, let's define a single group called all, and it can be a dictionary of keys. Okay, so where are we up to here? Okay. Come on, Emacs, tell me what to do. Alright, so we've got a group called all, the list of hosts, which only includes local hosts. We're not overriding any variables. Now there's another key here, I think it's _meta, and one of the items it has to return is host vars, and one of those items will need to be .localhost. I think that's probably all we need, and then if we do a JSON dump of this data structure to stand it out, I may have these arguments around the wrong way. Let's try that anyway. Oops. We'll just run it from within Emacs. Alright, so I actually think that will probably work, but it may not. So when we run this again, what Ansible will do is we'll see, okay, hosts is actually executable. So instead of just reading it, trying to parse it as an INI file, it's going to execute it, and it's going to expect JSON output in a certain format to inform it, you know, what my hosts are. Alright, so it's not happy. What are we doing wrong here? First of all, our groups need to be in a top-level groups tree. And our metadata needs to be exactly where it is. That's good. Let's just... Oops. Alright, I think that's it. I think that was the problem. So let's see if Ansible can handle the jandal. If nothing else, I'm hoping this will give you a taste of how you would go about writing a dynamic inventory script or reusing an existing one. Cool, very good. Okay, so moving on, what else are we covering today? Group vars. Now we can handle this, we can talk about this quite easily. What we'll do is we'll create a group vars directory, and the idea of group vars is, and the same with host vars, is you can override variables that say belong to a role or not belong to a role on a per host group or per host level. So in our crazy Emacs example, we might say we're managing 10 hosts, and some of those hosts are in a group called foo, and you want the foo hosts to have a different set of package archives than the default. In group vars, we're going to add a YAML file that is named after the group, in this case foo. No, that's a directory, sorry. And we're simply going to override one of our variables. We only have one at the moment. Oops. We're going to say for any hosts that are in the foo group, we don't want to specify any package archives at all. At this stage, what I might do is go back to using a static inventory file. So we've got a our host called localhost happens to be in the foo group. If it doesn't work, we'll try something else. And as you can see, there's no longer any items being substituted into package archives from the for loop in the Ginger template. So it's done exactly what we wanted. Now there's a few things to notice here. Our .emacs is actually invalid now, but we can ignore that. There's a few things to note here. Even though we've added some group level configuration, we haven't had to change our site YAML. We're still applying against a host called localhost, but Ansible is smart enough to know that that localhost belongs to the all group and the foo group. So when the play starts, we have a host called localhost, which needs to get its variable Emacs package archives from somewhere. Because localhost is in a group called foo, then we look up foo inside group vars, and we have the variable being overridden. So something that you might notice about Ansible is there is a lot of sort of logic that happens based on directory structure and the way things are laid out. This is good because it means that we're not having to sort of duplicate bits of kind of like configuration all over the place. It's quite a clean system to work with, but there is a bit of a learning curve to figure out what the interaction is between group vars, role defaults, and so on and so forth. You can even override variables on the command line or in the inventory itself. So getting to understand the precedence of all those different ways of variables being overridden is part of the learning curve. It does make for a very flexible system, I find. And certainly when you get to the point where you're managing multiple machines, if you've configured them to be in certain groups depending on functionality or even based on host name, you can tailor the behavior of your roles to account for differences in your system between hosts. So we've run the command ansible-playbook. You've seen that run several times. What else can we do with Ansible? Well, we can use it to do ad hoc commands. So for example, if I just run the Ansible command itself and I give it a list of hosts to run on, in this case it can be a group, it can be a comma separated specification. We're just going to say all. We only have one machine. -i hosts. Site, well, we don't need site YAML now. We need to specify a module. By default, the module is shell, so running a shell command. So we can leave it at that. And -a is arguments for I said command, but I mean, yeah, arguments for the module they're running. So if we give this something like, I don't know, host name, what it's going to do is it's going to run host name via the shell resource on all our hosts. As you can see, that's what it's done there. We have other modules, say the ping module, which will simply, doesn't need any arguments in this case. It will simply return the output, which is changed equals false. No changes happened, but there is a variable set by the module ping, which is basically ping with the value pong. Now we skipped over role testing, but there are some other sorts of tests that you'd probably like to perform as part of your CI build for your repo that contains your Ansible stuff. One of them is check syntax. Yeah, cool. So, not sure exactly how comprehensive it is, but certainly if that's something that happens as part of your build, and you know, as a precaution against, say, introducing invalid YAML syntax, then that's all good. If you just want to see sort of I guess, what would happen without actually changing anything, you can run with -c, and you would get similar output to as you would if you did the run, but no actual mutation of state will happen on your service. Now, depending on what tasks you're running, this doesn't always work. For simple use cases, it's all good. So, I mean, this is a simple way for me to check that actually my run wouldn't have changed anything at all, and I have that extra, I guess, comfort in knowing that if something had needed to change, it wouldn't have changed this time. There is a project called yamllint, which is more of a generic YAML syntax checker. We can use this to sort of give us some tips about what how our syntax is looking. It hasn't found anything here, but it's not easy to trip it up. So say, for example, I missed the YAML heading. Not always strictly necessary, but yeah, so in this case it's not an error, but it is a warning. So that's another thing you could integrate into your build for your repo. We talked briefly about ansible-cfg, the config file. Now this is its default location is etc. ansible config cfg, but you can have one in the root of your project to change certain behaviors of Ansible. One trivial example that I can think of would be, let's see if we can add to calsay. If you have the package calsay installed, then Ansible will use it as part of its output. So you'll notice that before, when we had output from Ansible, it wasn't a talking cal. One of the items you can configure as part of Ansible config, I think this needs to be defaults, is no cals equals 1. There's various things you can configure with ansible.config, including default location of roles, extra paths for roles, in case you want to say have some third-party roles in a separate directory. You can specify default inventory files, so you don't always have to do a -i. Now, I was going to cover some more advanced topics in this talk, which include how to create your own custom resource. Then that can be either a resource type like, say, ping, which we ran with Ansible before. You can create a myping or whatever else you need to do as Python code. You can also create Ginger 2 filters. We didn't actually use a filter today, but an example of a filter is, say, you might have a filter called upper, which changes a variable to uppercase. You can change, you can create notification plugins in Python, and this is how you might go about, say, feeding information from your Ansible run into your metrics and logging gathering tools. And finally, I was going to cover ansible-vault, which is a way to encrypt secrets. So inside group vars or inside host vars, some of those files can be encrypted, and they will be decrypted at Ansible runtime based on either a password you've specified or a password file you've specified, and the password file can be specified in your Ansible config. Thank you for listening. If you found this video useful, you're free to like it. If you want to be notified of future videos, then please subscribe to the channel. Okay, thank you. Goodbye.